Hey guys, what is up? This is Akhil back with another video. Today we are planning to do a weekly contest. So basically, I want to talk about what is competitive coding and why you should be doing it and how you should be doing it as well. So basically, you have to combine your data structure algorithms, maths, and logic skills, and do problem solving in a time bound um, against other competitors on different platforms like LeetCode or the special ones that I'm going to show you today. So this is a bindresearch.io where you can create your own contest, and this is free for everyone. So you can see it right now. So you can just have a practice where you can select, so you can make it public, and you have virtual contest. So you'll be given a set of questions randomly generated by the platform, so you have to solve it. So basically, so when you compete against others, the time constraint will be there, and this is what you want to be doing as well, and how you should be doing it. You can share it with your friends and join and do that together at the same time. So you can select easy, medium, hard, harder. I'm going to select the easy ones for today. We'll see if I can do or not. So this is just recording how I do problem solving on a day-to-day basis when I do competitive coding, and I don't know whether I can solve every question on the planet or not, and it is certainly not. And we'll see if I can solve all of the questions, and you can see me thinking how to solve the question and how I can tackle the question, or sometimes how I can lose the question as well. Let's figure it out. Start. So we're given an integer, return a list with each number from 1 to n except if it's a multiple of 3 or has a 3, 6 or 9 in the number. It should be the string clap. Okay, so except if it's a multiple of 3 or 6 or has a 3 or 6 or 9 in the number, it should be. So you have a timer running here, and within that time you need to solve all the 4 questions. Let's do that. So this is the number 3, which is divisible by 3 and which is a multiple of 3, and so we have to replace it with the string 4, 5, 6. So 6 has the number 6, and 9 is there, and 12 is a multiple of 3, and 13, in 13 you have the number 3, and so you need to understand that it should be replaced by clap, right? So you can have a result. So for I in range 1 to n plus 1. So if I percentage 3 is equal to 0, then rest will depend of clap. Elif, Elif, what if we have, so we can just define a function is 369, okay, function of number, and while num is greater than 0, what we have to do here is num is num divided by 10, right? And the number here is num percentage 10. If num percentage 10 in 3, 6, 9, you have to return true, right? And what else? return false. Elif function of I is true, or function of I true, you just have to do that. Otherwise, what we have to do is just return the number, right? And then, yeah, that's it. Return the rest. We'll see if this works. And so what we have to do here is, uh, okay, string. Okay, for this question, I think it's working. Yes, we can move on to the next question. So basically, what I did here is just this. So for this clap, we just have to know whether there is any 3, 6, or 9 in all of the digits of the number, right? And so we go from 1 to n, all over n, and then check for every number whether it's a multiple of 3 or not, and also whether any of the digits are 3, 6, 9, and that's it. We'll see the next question. So we still have 35 minutes left. So we given it two strings. Return the two strings interleaved starting with s0. If there are leftover characters in string, they should be added to that. So this is a, x, b, y, and c is z, right? So we can just have 2 pointers, 0 and 0. We can just have a string like this, and m comma n is equal to length of s0 and length of s1. For I, so as long as it has to be interleaved for I, while I is less than n and j is less than n. Okay, what else can we do? So for I in range n plus n, if I percentage 2 is equal to 0, that means it's an even. So when it is even, we just have to take from the second string, right? So no. So 0 starts with a and 1 has to be x, right? And so 0 is even and 1 is odd. So when it is even, you have to take from s0, right? So what we'll do here is rest plus is equal to s0 of I, and we can increment the I. Else rest plus is equal to s1 of j, and j plus is equal to 1. I think this works well only when the lengths of the strings are equal, because at some point we may not be having one of the strings. So what we'll do here, okay, the same thing can be done. Rest plus is equal to what we can do. This is just like the merge of the met sort, but there is no condition. So what I'm trying to do here is having 2 pointers, one at this and the other pointer at this. and just pass through the entire two strings and add up to the result, and then return the result. That should be fine. Sometimes the logic is easy, but the implementation part. Anyways, we can try doing this. Um, what we can do here, k is equal to 0. If k percentage 2 is equal to 0, it must be um, so s naught of I, and I plus is equal to 1, else result plus is equal to s1 of j, which should probably increase j. So either way, this has to be 1, increased by 1, k has to be increased by 1. And after that, while I is less than m, plus is equal to s mod of I, and the I has to be continuously incremented by 1. And while j is less than n, plus is equal to s1 of j, and this one has to be incremented as well. Return plus. I think everything is fine up until here. Yes. So we've solved the second question. So what we need to solve this question is, probably you should know what is merge sort, because many of the standard algorithms are very intuitive, and if you know them, you can solve many other questions, and that's why we need to learn algorithms and data structure along with the data structures. Just problem solving logic sometimes uh, do not fulfill your needs, so you need to learn algorithms, and for this, if you know the merge of the merge sort algorithm, it will be super fine, and we'll proceed to the next question. So if you didn't understand what I did here, so I essentially had two pointers, one at s0 at the beginning of s0, and the other pointer at s1, beginning of s1, and then eventually I've incremented k. So k denotes the final results point. So if I have this, so k denotes 0. If k is 0, then that means this is pointing to the first one. Although we don't have the result right now, we're just assuming that that character has to be filled. And so the k is here, I, j, and k. And what we do here is up until I is less than m is length of the s0, and up until j is less than s1's length, that is n, we have to keep incrementing k when you fill the this thing. And when if the k is 0, so this is even, 0 is even, what we have to do here is add the ith character, ith from s0 to the result, and increment k and as well as I. So now the I will be pointing to b, and the j will be pointing to x, and the k will be pointing to this thing. I mean the next position, k is 1 here. And so probably what we should be doing here is, now the k is 1, which is odd. So now we have to take into account of s1, that is incrementing j. And so we take x into the answer and increment j, and so now j is pointing to y, and k is pointing to and k value is 2. So that means we have to fill the position 2, and so again 2 is even, and the whole process repeats over and over again up until I is less than m and j is less than m. After finishing all of this, or if any of the pointer breaks, that means, so as long as we are seeing this, both of this has to be true. I should be less than m and j should be less than m. And so if when the pointers break at some point, like when we point I here, and when j has to be incremented to 1, 1 is less than this length, right? I mean, we don't have the next character for j. And so at that point, we break out of the entire while loop and just keep on adding s0's characters. That's what we're doing here. And in the same way, when as long as so suppose if the first string is smaller than the second string, this while loop works. And then keep on adding and incrementing j and return the result. So we'll move on to the third question. We are given a list of integers nums and representing a decimal number and nums of I is in. So we still have 25 minutes more and 2 questions left. So we are given a list of integers nums representing a decimal number and nums of I is between 0 and 9. For example, 139 represents the number 139. Okay, that's cool. That's not bad. It's more of a linked list. Return the same list and the same representation except modify so that 1 is added to the number. If 1 is added to the number, what should be the output? If 1 is added to this, it has to be 192, right? It's more of a, yeah, okay. So we have 9. By doing that, you have, okay. So if you have 9 and increase it to 1, increase it with 1, it has to be 10. And every digit has to be separated by a comma. This is a good question. So we'll see how we can attempt this question. Return the same list and the same modified representation except that 1 is added to the number. So what if, so we have 1 and 1. As long as there is no 9 at the end, so we just have to see that there has to be 20. And how the 20 came? So when we add 1 and 9, we get 10, which is 2 digits. So we have a carry of 1. So we have a carry of 1, which just adds up on to this. Okay. So we have a result. So and when we add a number, so basically when we add 1 to this whole thing, so we are essentially adding 1 here, which will give no. So we'll essentially add 1 here, which will make it a double digit number 10, and there is this carry. Okay, so carry moves forward and making it a digit, right? Okay, so while nums of I, so what we should be doing here is for I in range, or how should we go forward with this? So basically we have this nums and So we add the number at the last. Okay. So we have a carry of 0 and and num is equal to nums of I plus 1. The carry has to be the first digit. So if we take 10, and how do we obtain the first digit? Um, so, so 10 can be divided by 10. So when you divide 10, you get 1, right? Okay. While nums of I plus 1 is, so basically we get only, so while nums of I plus 1 is greater than 9, carry is equal to nums of I plus 1 uh, divided by 10. So, and number is equal to nums of I plus 1 should be number and carry. And so at the beginning we have this. So while carry is equal to, or while carry not equal to 0. So we have this one here, and I is greater than or equal to 0, right? So basically what we have to do here is we got the carry and num, and so we have to replace nums of I is equal to num, and so basically I has to be length of the nums minus 1. So we're beginning with the last digit, and what we are trying to do here is while carry is not equal to 0, so basically we have to add 1 at the beginning, which was said in the question. So the carry has to be 1 here, and carry, we got the carry 1 from, imagine there's an imaginary number beside this, and we got 1 here, so 1 has to be added to 1. And while carry is not equal to 0 and I is greater than 0, and so I is 2 here and the first, and so now carry is nums of I plus carry, that means we are adding 1 to this nums of I, so 1 plus 1 2, When 2 is divided by 10, we get 0. So that means we don't go to the next uh, loop, and the number has to be 2 percentage 10, which is obviously 2. And so we get 2 here, which is replaced here. Nums of I is equal to num. So, and the tricky part here is when we have only one digit, we have to append the carry at the first position. So what we have to do here is increment or decrement I, keep on decrementing I. So when I is equal to 0 at this position, so here I is equal to 0, we calculate carry to be 10 by 10. Carry is 10 divided by 10, it is 1. Carry is 1, and num is 10% is 10, which is 0. So num is 0, and so we replace this one to be 0, and now we got I minus 1, which is minus 1. 0 minus 1 minus 1. And so when we come here, carry is definitely not equal to 0 because it is 1, and I is not greater than or equal to 0, so it breaks. So if I is less than 0, that means we have to insert the carry at the first place. So what we do here is nums dot insert 0th position, we have to insert the carry, and we have to just return the nums. You think this should work? This is a pretty interesting question. So we got a if I is less than 0, okay, and carry, yes. Whew. This is a very interesting question, guys, but nevertheless we are solved. We'll go for the last question. So if you didn't understand what it just did here, I'll brief it now. So what we have to do here is add the carry. Carry is 1 at the beginning, and the index we are passing from the right to left of the array, because that is how we do maths. When we add a number, we just take the carry forward to the left and just add the numbers. So we add 1 here, which will be 2, and so the carry is not a double digit number, and so we got the carry has to be 0, and so we just stop the loop. And this is the main part, or the tricky part, or the test case that you need to check, because you need to append another character here. So what we have to do here is we add 1 here, which is a double digit number, but still this is we have a carry, and the numbers here are over. At that position, at that place, we have to just add the carry at the beginning of the list. That's it. This is pretty easy and cool question. Prime factorization. For we're given an integer n greater than 1, find all of the prime factors and return them in sorted order. Prime factors. You can write out a number as a product of prime numbers where which are its prime factors. For example, 12 can be written as 2, 2, 3. Prime factors. So all the factors have to be prime. That's it. And we have to take all of the. What we have to do here is divide it. So basically we have to find out all the prime factors that are except the 1 and n, all the factors that are 1 and n, between 1 and n, and then the next thing has to be prime factorize every single number. That's okay. So to find the factors, you can just go with, okay, so first we have 2, and so we have the factors, or maybe the 12 can be written as 8 plus 4, while I into I is less than or equal to n. So this is just a faster way of finding the factors, and if n percentage I is equal to 0, factors will depend on I, and q is equal to n by I. If I is not equal to q, factors will depend on q. The next thing is I should be incremented by 1. I think this should be enough, and the best thing about this is so we have to prime factors each and every factor in here. I don't know how to do that. Greater than 1, we have to return that in sorted order. So we got the factors, but they are not prime. So if you have 6, 2 and 3 are the factors. If you have 12, so basically 3 and 4. 4 is not a prime number, so we just have to factorize that. Yeah. So 4. So the next thing here is return the factors. Factors would depend on we just have to take an integer, and if it has to be prime, check if it is prime or not. Factors. I has to be there. So first we need to check if it is prime or not. So anyways, this seems like a repetition, but we'll try. I is equal to 2 while I into I is less than or equal to n, then percentage I is equal to 0, factors plus is equal to 1, q is n divided by I, and if q is not equal to I, factors has to be implemented by 1. And the next thing is if factors is greater than 0, probably return false, because that's not prime if you have factors other than this, other than 1 and n. So the next thing has to be, so what if n is equal to 1? No, n can't be 1. Okay, none of this, then we just have to return true. So this is probably it to check whether something is prime number or not. So f is prime, f is prime of I, so we just have to append I, right? And isn't, if it isn't, then factors dot append of prime factors I. And the same way, f is prime of q, just append the q, otherwise factors dot append of prime factors of q. And this should be it. So return the prime factors of prime factors of n. This is a lot. Let's see if it works. The best thing here is we don't know what's wrong. Local memory factors request factors plus is equal to 1. So we have factors 0 initialized at the beginning. And the next thing is segmentation fault. So mostly segmentation fault occurs when we run out of memory or try to access something out of the memory. So this can't be append because this has to be extend, which will return still the same. We got 2 minutes left and we'll try if I can solve this. So basically we are trying to find whether a number is prime or not. And the next thing here is, this is an n. So we got 2, 2, 3. Okay, this is a time limit exceeded. And where are we? Yeah. So here we aren't incrementing I. So that should be the problem. So we got 2, 2, 3. But along with that we got 3, 2 as well. Why would that be possible? Hmm. So for the 12, we'll start with 2. 2, 2's, so 2 is divisible by, so this is prime. So 2 should be prime. Time is up, but still we can solve this question. 2 is prime, so we just append 2. And 12 by 2, it has to be 6. 12 by 2 is 6. And q is 6. 2 is not equal to 6. So we come into this loop. And is prime of 6? No, it's not. Because we have all of the factors. So factors are append. No, it's not. So we just come here. And prime factors of 6. And so for the prime factors of 6, I starts from 2. And 2 is again there. So basically for the prime factors of 6, 2 will be appended. And 3 is prime of 3. So 6 brings in 2, 3. And that appends here. So we have 2, 2, 3. After this, so we go to 3 here. 3, 3 is 9, which is less than or equal to 9, which is less than 12. Okay, so is prime of 3. So this will add up all other. So this will add up extra elements. How can we avoid this? So we don't want all the factors. So what we are doing wrong here is we are taking all the factors of 12. That is 2, 3, 6. So 2 and 2, 3, 6. And we are factorizing every single thing of it. 2, 3, 6 will bring in 2, 3, 2, 3. So that shouldn't be the In general, how would we do prime factorization? So we'll start with 12, divide it with 2. So I think I cannot solve this question, but let's see if we can do it in 5 minutes or less. So we're almost there, but we have extra elements, but there is something wrong with the logic. Prime factors. Hmm. 4 which can be divided by 2 into 6. And the prime factors of 6, it has to be 2 and 3. Sometimes we have elements which are other than 2 and 3 at that time. How could we solve this? So we just don't want all the factors. And so the thing that you can learn from this mistake is that uh, don't try to code before you manually solve the question. So basically for 12 we have to have all the factors. Likewise of n. So n is divided by, I don't know how to solve this. Let's see the solution and understand. So what did he do here? So we have the result here, and while n percentage 2, so if it is even, so we're dividing it with 2. As long as it is even, we are having 2 into the answer. And when there is something that isn't even, then we have all of the prime factors coming in. So what do we do here basically is that we start from 3, square root of n. Okay, so we have when we have 6, start with 3, square root of 6, square root of 3 plus 1, incrementing by 2. So when this is so basically we're trying to and take into account all of the prime factors starting from 3 up until square root of n, and the increment has to be by 2. We'll see why this is 2. And as long as it is dividing, we have to take n, or sorry, I, and if n is greater than 2, accelerate at n. Okay, so if itself is n itself is the prime number, then that has to be taken into account. So this will be taken. So what they are essentially doing here is taking all the prime factors from 3 up until square root of n. So this is why we need to know max, guys. So there are questions that are based on max that we might solve or not. So I think this is out of my knowledge. So see you in the next one, guys.